So I'm giving you a short lesson on the extreme value theorem and then a couple of examples where you should try to work through them. So the extreme value theorem says that if you have a continuous function on a closed interval, then you're guaranteed a global minimum and a global maximum. So that's not the same thing as a relative min and a relative max. It might be, but it doesn't have to be. Look at this example. Here's a function continuous on a closed interval AB, right? So closed meaning at the endpoints, right? I'm just cutting off that interval. And this is now we have definitely have a global maximum, which is the highest value of y on that interval, which is found in this case at f of b, and a smallest value of y. The smallest output in this case is occurring at a relative minimum. So what that means is that when you guys are trying to find a global maximum and a global minimum, you have to consider relative extrema, which you know how to find and justify, as well as check the endpoints of the interval if you can, if it's closed. And then if it is closed and it's continuous on that closed interval, you're guaranteed somewhere to find a global max and global min. So you're comparing values at endpoints with relative extrema. Even in this case, which is pretty extreme, you have a constant function. This is a function that is continuous on a closed interval AB. You are guaranteed global max and global min. In this case, the global max equals the global minimum, which is just equal to the output K. Okay, that said, even if you can't use the extreme value theorem, that doesn't mean that we won't ask you to try to find global maximums and global minimums. Consider this particular function on the interval that looks like this from A to B. So my interval is going from A to B like that, okay? So this definitely has a global minimum of f of A, but it does not have a global maximum because you want to tell me that the global maximum is f of b, but f of b is not defined on this interval. F of b is not even defined on the function, and it's certainly not defined on the interval. So this has a global minimum, but it does not have a global maximum. You weren't guaranteed one anyway because you couldn't use the EVT here. This function right here is continuous on the closed interval. I would have to consider, if I knew the equation and not the graph, all of the values at the endpoints of the interval. So f of a compared with this relative maximum and this relative minimum and this relative maximum, and then the value of f of b. I can see here that f of b is giving me the global minimum, and I'm seeing that the maximum, the global maximum is occurring at this relative max. Okay, over here, if I give you a function like this, but I'm keeping the interval open, it means really you're thinking of it as this interval right here where you can't consider the endpoints at all. And so you would have to find relative extrema, but you can't find the values at the endpoints. This is an example where this function does not have a global max or a global minimum, because where you would want the maximum to be, you can't consider it. And where you'd want the minimum to be, you can't consider it. This is a case where you would have to justify that reasoning with limits, and I'm going to give you an example with that. Over here, I've got a and b. So what that this function doesn't have this function has a discontinuity. I can't use the EVT, but I can still tell you that the global minimum is here at f of a, right? It's f of a, and the global maximum is wherever that relative max equals. So in general, this is kind of a recipe for doing problems like this, where you have a continuous function on a closed interval where you can use the EVT. You're going to consider relative extrema, right? You're going to consider the values at the endpoints, and then you're just going to compare all of the outputs. Right here, you would compare, and you would find that f of -1 is the smallest value of y on the interval, and that this relative maximum is the greatest. So this is like one step beyond what you guys did in 4A, because I'm recording. Okay. This is one step that you guys did in Unit 4A. Before you found relative extrema, you still need to do that, but now you need to compare with values at the endpoints. Okay, so here's an example. I actually wrote up this answer and it's on the website. But your job right now is to find all relative and global extrema for this function on this closed interval and justify your reasoning carefully, and then you'll compare it with the correct reasoning for a global extrema. Pause the video and try it. Okay, so the EVT guarantees that the function has a global min and global max since f is continuous on this closed interval. You have to find the relative extrema first, and you still have to justify them the way we talked about it with the 3 pieces of information I said you needed. Then you need to find the function values at the endpoints of the interval, and then you need to compare the values of the extrema to the function values at the endpoints. Then you need to have a sentence explaining what the global extrema are. So in this example, you were finding the relative extrema, okay, from the same way from the last unit. I went through all that work, and here's what your conclusion should have been for that part of it. So f of -1 is 4, is a relative max, since f prime -1 is 0, and f prime changes sign from positive to negative at x equals -1. Okay, same thing for the justification for a relative min. I found a relative max and a relative min. Then I'm finding the function values at the endpoints. Here they are, f of -3 and f of 1.5. And now I'm going to compare all of those outputs, right? The outputs from the endpoints and then the outputs from the relative extrema. I'm seeing that the smallest value I'm getting is from an endpoint, and the largest value I'm seeing is from a relative maximum. Here's the justification. Okay, this is the part that's new for you. Okay, f of -3 equals -16 is a global minimum because -16 is less than or equal to f of x for all of the x in the interval. It's really just very straightforward. It's just some mathematical notation, right? I'm telling you what the global minimum is, and I'm saying, hey, it's because it's the smallest value on the interval. That's how you write that. F of -1 equals 4 is the global maximum. Why? Because 4 is greater than or equal to all the outputs, all of f of x, right? Greater than or equal to f of x for all x on the interval. That's the justification. Okay, I want you to note if f of -1 was less than the limit of -3, what was I trying to say here? I don't know why I'm saying that. I think this had to do with something else. F of -1, I don't know. I had that for something else, I think. I'll just take that off. Okay. Okay, so here's another example. I know you guys know that this is a parabola, but I want you to try to justify a global max and a global minimum for this one. So pause the video and try it yourself, and then you're going to compare it with my work. Go. Okay, note that the extreme value theorem does not apply in this case. So you are still going to go through though and try and find relative extrema and try and check to see what's happening, right, as x approaches -infinity or positive infinity on this graph. So you guys know that this is a parabola. You know how to find the vertex. It's 2, 3. This is not really one where you need calculus. It's also opening down. So parabola opening down at 2, whose vertex is at 2, 3, means that 3 is going to be the relative max as well as the global maximum. There are no relative minimums. So the global max justification is, right, you justify your relative maximum, but then f of 2 equals 3 is the greater than or equal to f of x for all x on the interval. Therefore, f of 2 equals 3 is the global maximum. Okay, that's straightforward. Global minimum requires limits. There is none. Why? Because as x approaches infinity, the function is getting smaller and smaller, right? It's getting more and more negative. Same thing as x approaches -infinity, f is approaching -infinity. So there is no global minimum, but the justification requires you to say something about these limits. Even one of these limits would be enough to say that there's no global minimum. Right, there's the graph, but never tell me to look at a graph for your justification. That's just for you to kind of understand what's going on. This is the most basic example. Again, the EVT did not apply here, but we can still ask you about global max and global min. So let's go back to the previous example, but this time I'm changing the interval on you. And now I want you to justify again global max and global min on this particular interval. Pause the video and try. Okay. EVT doesn't apply. There may or may not be global extrema, so let's check. You still need to find and justify relative extrema, right? So, and then here's what the number line looks like when you do that. So you should see that we're only looking at the interval from -3 to infinity. I kind of like stop my number line right here with an open parentheses here. This is the interval from -3 to infinity, and that's how you do that on the number line. But notice that as when x is more than 1, the function just continues to increase. That means that there's no global extrema, right? The limit of f as x approaches infinity is infinity. So there's no global maximum. It continues to grow. So as x gets big, f gets big. So no global maximum, that's the justification. It requires a limit. Okay, there's my explanation right here. F is increasing, the limit of f as x goes to infinity is infinite. Now, a little trickier to justify a minimum. So there definitely is a relative minimum. You've already found it, right? F of 1 equals 0 was the relative minimum that you found and justified, right? But then you have to kind of see what's going on at -3. So this is what that other note actually was pertaining to. F of -3 is not defined on this interval. So you can't actually consider f of -3 here, right? Because it's not part of the interval. This is open. But what you have to do is say, wait a minute, if I could look at f of -3, in other words, the limit of f as x approaches -3 from the positive side, that would have been that's -16. And that actually is smaller than f of 1, which equals 0, my relative min. So there is no global minimum here because -16 is smaller than f of 1, which is 0, right? F of 1 does not have a global minimum. You can't consider that -16. It is smaller, right, than the relative min of 0, but you can see that you can't consider it. And you're seeing that as x approaches -3 from the positive side, you're getting values smaller than 0 because they're going to -16. Okay, so those are two examples. And then I handed this out to you guys. Everybody should have this. This is like definition of what an absolute max is. It's basically saying the greatest value of the function. Similar definition for absolute minimum. Here's the extreme value theorem written for you. And here are the two justifications that are new that we just talked about.